Hey, it's Plumber Tom. Don't forget to check in the comments below for a link where you can find additional resources like practice tests and courses that you can take. Your support helps me to be able to create more great content. Thanks for watching. Hello, welcome to this presentation of the International Fuel Gas Code. My name is Thomas, and in this video, we are going to look at Chapter 3, which is all about general regulations for the installation of gas systems. All right, let's get into Chapter 3, International Fuel Gas Code, now that you have your book out in front of you and you can follow along with me, which you know I always encourage you to do. That's the best way for you to internalize this. You can look at what's on the screen, I can tell you all about it, but if you connect that with what's in your book, then you're going to be better off when it's time to take a test. So follow along with me here, and we're going to start in Chapter 3, but let me remind you of a couple of things. First, before Chapter 3, there was Chapter 1, which was scope and administration. This is the same sort of stuff that we find in the plumbing code and the building code, where they just kind of spell out the rules of the game and how we handle permits and inspections and stuff like that. Also, don't forget that in Chapter 2, there are definitions. And the definitions chapter for the International Fuel Gas Code has a lot of definitions that are important for you to understand. Words that are specific to the gas systems and gas piping systems that you would need to know in order to pass a test, but also to be competent as an installer. So make sure that if you don't understand any words along the way, that you go and check that out in Chapter 2, all about definitions. All right, let's get into Chapter 3. We start out with just the basics. 301.1 is the scope. It says this chapter shall govern the approval and installation of all equipment and appliances that comprise parts of the installation regulated by this code. So anything gas, we're going to cover it. This general regulations, again, is kind of a broader perspective. It's not specific to the pipe or the appliance, but like as we are installing these systems, how does that affect everything else? What specifics are required? Now, 301.2 says that when it comes to energy utilization, it's important for us to go and look at the International Energy Conservation Code. That has the specifics about how we handle these installations in a way that will conserve energy. Let me maybe specifically state things like the proper insulation of a building, which is going to, conserve or preserve the temperature that's inside of it. So if we're going to heat the building and we have good insulation, that's good. And so those sorts of things are in the Energy Conservation Code, and they refer us to that because that's an important piece as we are using these systems. Let's go on to 301.3, where it talks about listed and labeled. You can see here an example of an old plate, information plate that's on the side of a furnace. 301.3 says that appliances should be listed and labeled. We have to have that specifically there so that we have information about that appliance. 301.4 talks about the labeling, and it says it has to be done in accordance with that section. There's some testing requirements and some inspection and identification requirements listed in there. Let's go on to 301.5, which gives a list of the specific information that is required on any of these labels or nameplates. And there's quite a bit here. First of all, it has to be legibly written, and so legible lettering. That means you can see it and read it easily. Then you have the manufacturer name or trademark. We need to know who made it. Then we have the model number and the serial number. That's going to be specific to the appliance and help us identify that appliance. Then we have the seal or mark of a testing agency. So that third party that comes in and says, yeah, we've checked these appliances and this one passes certain standards. It should also have listed the BTU rating, the type of fuel, and the minimum clearances you have to maintain around the appliance. Well, that's quite a bit of information, but all very useful as we're doing installation.
Hello, this is Steve at HVACPartShop.com. Today we're going to go over how to find our model and serial number on our furnace. Okay, so here we are in front of the furnace. First thing we got to do is find our data sticker. So we'll take off the top door of the furnace. This is going to be their burner compartment. This is where usually the data sticker is located.
So for a furnace, I have to go and take the thing apart. Now, you know, they might be like, it's just a panel on the front. You can just pop this and that and it'll come off. But sometimes I have to get tools out. And if I have to get my tools out to go and look at one of these, well, I think that's too much work.
A lot of times it'll be underneath the burner or on the left inside wall of the furnace. In this case, we'll get our flashlight as well so we can see what we're looking at. In this case, it is on the left inside wall of the furnace. Here's our data sticker here. This data sticker contains a lot of information that the technician will use.
I should be able to get into it easier than that. Like, I should be able to walk up to it just like a water heater and be like, what are you all about? What's your model and serial number, you know? And see that information. I really don't comprehend why they always stick those in the furnaces inside.
Also, right here is where our model and serial number is going to be. Okay, so it may be best if you take your installation manual and go ahead, now that we know where to find our model and serial number, is to go ahead and jot them down on the front side of your manual.
All right, I have a little exercise for you here. This is the label for a Bradford White natural gas water heater. Just took a picture of a water heater that was installed, right? What I'd like you to do is look closely at this image and see if you can identify all the things that should be on a label. I'm going to list it off. You look for it. Here we go. First of all, it should be legibly written. So yeah, hopefully you can read this. Look for the manufacturer's name or trademark. You see that on there? Next, look for the model. You see where the model is listed? How about the serial number? There's also going to be the seal or mark of the testing agency. Can you see where it's been certified? Now on this one, there's actually two. The top part got cut off there. It says certified. There's a stamp above that, and then there's the AHRI certified. So several have looked this over to make sure that it's meeting standards, right? Look for the BTU rating. Do you see where it lists out the BTUs for this particular water heater? What about the fuel type? Can you see where it says that this is natural gas? And how about clearances? It specifically spells out clearances in front, to the right, to the back, from vent connector. So those are all important. Now, in addition to that, as we look this over, there is more information than what was required, right? It says that here the capacity is 40 gallons. You don't have to put that on there, but it's there. Other information, the maximum supply or gas pressure at the manifold. Also, this one specifies it's for a closet installation. You can put it in a closet. Check this out at the bottom. This appliance is equipped for use at high altitude. What does that tell us? That tells us that the orifice in the gas valve has already been adjusted for the gas difference at higher elevation. And we get into that later in chapter 4. I'll explain how that density changes as we get into higher altitudes. But just pointing out here, you can't install this water heater at sea level. It's not going to work right. And you can't install a water heater that's made for sea level at higher altitudes. It's not going to work right. I think it's good for us as plumbers to be able to look for this information about appliances, especially as we get into gas sizing. You need to know about each appliance, and this is where you look on the label. Wait, stop everything. Do you see that? Look closely in the corner here. The sticker is peeling. Yes, labels are sometimes actually just stickers. And let me warn you, you do not want to peel that sticker. As much as the coroner may be calling to you and asking you to peel it off of the tank, don't do it. It will void the warranty. All right, moving on to 301.6, it talks about plumbing connections. There are appliances like a water heater that have to have connection to the plumbing systems. In those situations, it says, look to the International Plumbing Code for details as to how that should be handled. As plumbers, we should know that really well. 301.7, fuel conversions. Appliances often are able to convert from either natural gas to propane or the other way. And it comes down to the orifice. An orifice is a small opening that allows the gas through into the burn chamber. And there's a difference on how much gas you want to allow, whether it's natural gas or propane. So basically, it's just a different size hole. And many appliances can be changed or converted from one to the other. On the other hand, some appliances are made from the manufacturer set for one or the other. Water heaters often come either as a natural gas or a LP propane water heater. So you want to make sure you're getting the right one when you install. But it's important to understand that you can make those conversions. One example of doing a conversion is the Navien tankless conversion kit. Most of the Navien water heaters have that kit right in them. So you can install and then just open it up. It has a simple instruction. You swap out the orifice, seal it back up, and then tell the computer you've gone from natural gas to propane, and it's ready to go on the other gas. Now, if you don't, on any of these appliances, just warning you, you could destroy it very quickly. A propane system with a natural gas water heater will burn up the heat exchanger and destroy the water heater. So make sure you get that right. 301.8 talks about vibration isolation. Some appliances or some equipment's going to have some isolation so that it doesn't transfer noise into the building. 301.9 talks about repairs. If we're repairing any of these gas systems, it says defective materials or parts shall be replaced or repaired. Anything that we know is defective needs to be corrected. 301.10 talks about wind resistance. 301.11 talks about flood hazard areas in regard to how these systems and appliances are installed. 301.12 talks about seismic resistance. And there are some seismic meaning earthquake proof, right? We're going to set this up so that if the water heater's in an earthquake, it doesn't just fall over, bust all the lines, and cause a bigger mess than it's already going to be when there's an earthquake, right? 301.13 talks about ducts and refers us over to the International Mechanical Code. 301.14 talks about rodent proofing. It is not uncommon as we're installing these systems to create a sidewall penetration or somewhere that we've made an opening from the outside of the building into the building where rodents can get in, or other little vermin, insects, whatever. So this section emphasizes the importance of closing up, sealing up, making sure that whenever we penetrate a building, it's not going to be an opening that would allow rodents in.
Ooh, I love people food. Yeah, people food's the best.
I say we move in with these people. Yeah.
Hey man, you got cake on your face. So do you.
301.15 gives us prohibited locations and specifically elevator shafts. We see this in the other codes, the International Plumbing Code. Elevator shafts are designed specifically for the elevator and its equipment. And even though it looks like a great place to run pipe because it's got this wide open chase all the way up, it's not for us. Let's go on to section 302, which is about structural safety. This section of structural safety is comparable to what is in the International Building Code, but it's also in the back of your International Plumbing Code in Appendix C. So in each of these codes where we're going to be installing piping systems into an existing structure, they want to make sure that we're not going to destroy the structure or the strength of the building as we install those pipes. Let's have a look. 302.1 says, the building shall not be weakened by the installation of gas piping. So if I'm running pipe, I'd better not be hacking things apart to where it could be a structural problem, like the building's not going to hold the weight. 302.2 talks about penetrations of floor or ceiling assemblies and fire-resistant rated assemblies. There are some buildings with designated spaces that have divisions or firewalls to contain a fire so it doesn't spread throughout the building. Anytime we penetrate those firewalls, we're going to have to do something. Many times it's just caulk, fire caulk around the pipes. But something has to be done. 302.3 talks about cutting, notching, and boring in wood members. Now, there's a lot here, so let's get into some of the details. 302.3.1 talks about engineered products. We're talking like joists, I-joists, or glulam beams, or other things that are manufactured and are made of wood. Before we drill through these or alter these structures, we need to make sure that we understand what the manufacturer requires as far as size of holes and distance from bearing walls and things like that. I'm not going to go into all the details of that, but just know that engineered wood products have those specifics, and we should be aware of that. A simple rule of thumb for plumbers would be for every 1 foot that you are away from a bearing point, you can do a 1-inch hole. So if I have a 4-inch hole, I need to be 4 feet away from bearing point. Now, as we look at this picture, there's a duct that's been run right by the bearing point within a couple of feet. Probably not meeting that standard, but again, we'd have to look into the manufacturer's requirements and see if that works. Let's talk for a minute about solid wood joists. This is older construction, houses that were built, many years ago, they do solid wood, but this still can be installed and used. So here we go, 302.3.2. When it comes to joist notching and boring, there are certain specifics as to what we can and cannot do. On the top of this diagram, we see the length, overall L, and then on the right side, we see the actual depth, the dimension D. Now, there are certain places that we can and cannot go. Notice in the middle that we are not allowed to drill, notch, or do anything in the center third of the joist. We can on the right or left. If we notch into it on the underside, we can only go 1/6 of the depth of the joist. Notching overall is just not a great option, seriously. Drill a hole or find something else to do. If we're going to drill a hole, look at this one, it has to be a maximum of 1/3 of the depth of the joist. So if I have an 8-inch joist, well, that's only going to give me about 2.5 inches. I shouldn't be running a big 3-inch pipe through there. Look over here on the right side. Once again, if we're going to notch, we're not talking about depth on this one. We're talking about the width of the notch. It can only be 1/3 of the depth of the joist. So we see a limit on how deep we can go and how wide we can go. As you chop into that, you're really weakening the structure of that joist. Okay, a couple other holes here. They have to be 2 inches away from the top at a minimum, 2 inches from the bottom, and 2 inches from each other as we're drilling through.
Luke, you must look at the terrible damage to these joists. Behold the awesome destruction of incompetent workers.
302.3.3 gives us information on stud cutting and notching. So we're just going to notch into the side of the stud. And 302.3.4 gives bored holes. That's where we're going to drill a hole. Now there's the same thing that we see in the building code and plumbing code, but here it is. You have a bearing wall, which is holding weight, and a non-bearing wall, which is not holding weight. Let's go to the right side here first. Notching. If we're going to notch into the face of a stud, you can go 25% on a bearing wall. If it's non-bearing, that means it's just a partition wall, we're going to hang sheetrock on it, you can go 40% on a non-bearing. Now we can create a bigger opening for a pipe if we drill it. Drilling a hole, or boring a hole as they say in code, leaves a better structural strength. So we see on the left side here, you can drill a hole that's 40% of the depth of the stud on a bearing. And on a non-bearing, you can go all the way up to a 60%. So these proportions are really important for us to remember as we're going in. If we take out too much, if I notch out more than half of that stud, it's not going to be strong enough to hold like it should. If I drill a hole that's too big and takes out 70% of the stud, what's left? I mean, why is that stud even there anymore, right?
You thought I was done, but I have more for you to see.
Now that might bring us into a whole different discussion about like, hey, framer or even architect, why don't you give me a wall that's thick enough, if I got to put plumbing or pipes through this, thick enough that when I drill it, I'm not going to have these problems with structure. That'd be nice. Give me a 2x6, a 2x8 wall. If they're giving us 2x4, sometimes it's really hard to meet these requirements. One other point as we look at the drilled holes or bored holes is that you must stay away from the face by 5/8 of an inch. That's a little more than a half. You just want to make sure that there's some structure at the face as we're drilling through those holes. 302.4 talks about alterations to trusses. Trusses are often used either for floors or especially for roofs, and they are very important structures. If you affect them in any way, they will not be strong enough to do their job. So when it comes to alteration of trusses, it says that truss members and components shall not be cut, drilled, notched, spliced, or otherwise altered in any way without written concurrence from a design professional. So if you really have to, which I don't see any reason why you really have to, there's other ways around this, but you shouldn't touch them unless you've talked to a structural engineer. We've talked about wood. Let's talk about metal buildings, often seen in commercial settings. 302.5 and 302.6 goes over the cutting, notching, and boring of holes in structural steel framing and cold form steel frame members. If we want to summarize what's in those two sections, basically it's like if you're going to alter these steel structures, you have to get that permission. Same thing, talk to an engineer. Code says it has to be as prescribed by a registered design professional. That means, the engineer said, yes, you can do this. Now, on a building, the steel, hang below it, right? There's usually ways around it. We don't very often have to go blasting through steel. What about steel studs? 302.7 talks about cutting, notching, and boring holes in non-structural and cold-formed steel wall framing. So when they put up these steel studs, when it says cold form, they roll out the steel and then stamp it into the shape of the stud, and then they usually poke some holes in it, right? If those holes line up for us, great. That works for electricians. But most of the time for us, as we're sloping pipe or moving water lines through, we have to create our own holes. So if that's the case, keep in mind the requirement for holes here for these studs to maintain structure. It says the hole should not exceed 1.5 inches in width and 4 inches in length. It also says that they should be spaced out 24 inches center to center and should not be less than 10 inches from a bearing point. That would be from the bottom end or top end of the stud where it's connecting and bearing. So, what does that do for us as plumbers? Sometimes we have to poke holes in these. Best to spread out the holes if you're going to be running water lines and drains through there. And do your best to maintain the sizes. It's the same thing as we talked about with wood. I mean, if they're giving us 2x4 inch, steel studs, and we're supposed to put a bathroom group in there, what do? You do your best, right? All right, so we've covered section 301 and 302 in the International Fuel Gas Code in Chapter 3. And we talked about some of the general stuff and the structural safety, trying to maintain the building. Join me in the next presentation. We'll look into 303 and move forward into the chapter from there. I'll see you then.